All right, good morning for PreCalc. I really got to get these up online. So we're still reviewing today. Okay, we have our test up and we are reviewing. And we're still looking, I think we're still looking at rational functions here. But we were not at the beginning. We were kind of close to the end here. Okay, we were past this because we did one. We could do another one of these. It would not hurt to do more of these. Okay. All right. All right. Yeah, let's take a look at this one here. Okay. So we'll go back. We'll go back as well. But here we have a negative x squared plus 2x plus 8 divided by x plus 2. All right. And if you don't mind, what I'm going to do here is I'm going to pull that negative out because I find it difficult to factor if that's not a 1. So we have x squared. But remember, you got to get everybody. If you're going to pull that negative out, you got to change the signs for everybody here. All right, and we have x plus 2. Okay, very good. So now can we factor this thing, right? And that's going to look like x minus 2, or x minus 4 rather, x plus 2. Don't forget that negative, all right? So we have negative 4 plus 2, that gives us a negative 2. That times that is negative 8. I think we're good. Now what's going to happen here? All right, there's some stuff that's going to cancel here. Right? These two pieces, those are going to cancel. So what are we going to be left with? We're left with negative x minus 4, and we also have the idea that x cannot be negative 2. Okay, so you don't have to go around and carry this whole function around anymore. You do have to remember that x can't be negative 2 because this was part of it, but this function is going to look like this thing. Okay, and I am very confident that everybody that is ever going to watch this video can graph that line there. Okay, so negative x plus 4, right? So that's a y-intercept of 4, right? And then we have when x equals 4, we've got a point down here, okay? Or you could, go ahead and do it this way with the little staircase. And if x were to be negative 2, I mean, it can't be, but just humor me and say, what if it was? We'd have negative 2 plus 4. That would be 2 plus 4. That would be 6. So at the point negative 2, 6, we have to write in like a little hole here, okay? And I'm just going to ask you to pretend that these line up on a straight line. They're supposed to, okay? But there we go. All right. So I'm not going back. I'm not finding asymptotes. We are not finding horizontal asymptotes. We're not doing any of the rational stuff. Or since we got some stuff to reduce and it turned into a line once we reduced it, we're using all of the tools that we have to graph lines, not the tools we have to graph rational functions. Okay. So if you can cancel these, this is what happens when you cancel. This is your common factor. Okay, that's why it's important to always check for them, because if you're going to go through here and put in an asymptote and then you're going to put in a horizontal, you're going to put in a vertical asymptote and then a horizontal asymptote. No, that's not it. Okay, there is no horizontal asymptote. This is a line. So be very careful about that. Finding different points, that's fine. Oh, they wanted to know the domain, didn't they? Okay, so my domain is all the numbers except for negative 2. So in face-to-face class, I would have told you to, you can write it this way. But we should practice writing an interval. This means all the real numbers except for negative 2. Okay, But your book, and actually all the books that are following this for a very long time, are going to be interval notation. So we're just going to write it that way. So we're going to say all the numbers except -2, which looks like negative infinity up to -2, union -2 up to positive infinity. Okay, so that's what the book is going to want to say. That's what the computer is going to want to say. All right, but that's how we do that. Okay, so that's it's a tricky problem because you have to remember you have to factor. But once you get that done, your life should be a lot easier once you've eliminated that point. All right, what else are they going to have us do? What we have here, we have negative infinity up to -2. Okay, and then union, where's my union? And then we have -2 up to positive infinity. Do all of this here, but let's see what we got. Kind of nice. They give us like one at a time to do this. Simplifies to negative. Oh, okay, fine. Negative x plus 4. And then we're going to let me do that. X can't be -2. I don't know why they asked us the same question twice here, but there we go. Any vertical asymptotes? Nope. Any multiple equations of asymptotes? Nope. So, nope. All right. Identify the values of x corresponding to where the function is discontinuous. X is equal to -2. Again, this is the third time they're asking us. All right. And identify the graph. Beautiful. All right. This looks pretty close, right? -2 up to 6. Downward slope. Looks like 2 here, or 4 rather, for intercept. Pretty happy with that. Oh, and then that was right. Okay, we're good. Okay. Oh, I so miss face-to-face classes. Because this would have been what I would have asked you to do. You would have been doing this. All right. Okay. Oh, I think we did this one yesterday. I'm gonna have to remember that because that variation runs the gamut from A to A. Okay, so find an equation of the function that meets the given conditions. Okay, we have. Oops, what do I want? I want this thing. Okay, so what did they ask us to do? They said x-intercepts are at 4, 0 and -5, 0. So that means, right, x-intercept, this means when y is equal to 0, this is the x values, right? And you can see, hey, look, y is equal to 0 here. So regardless of whatever p of x over q of x, right, that's a fraction, we set it equal to y, 0. So all we have left here is p of x is equal to 0. All right, so I don't even care what the bottom is looking like right now. I just know that the right-hand side is 0, okay, because I'm getting my intercepts. And we have the idea here is that x is equal to 4 or x is equal to -5. That's what we got over here. All right, so we can recombine this and say that's x minus 4 equals 0 or x plus 5 equals 0. Okay, we're just swinging this over to the other side. When I put this all together as one function, right, as one quadratic now, I know it's a quadratic because we had 2 of them. We have x plus 5. Okay. Normally I would say don't worry about trying to multiply these out, but I'm looking at my answers. Excuse me, and they are all multiplied out. So yeah, let's go ahead and say that's x squared. We have minus plus, so it's a plus x minus 20, it looks like. Okay, but we're gonna hang on to this just in case, right? Because that might be more useful in some cases. They're both the same, so we're just gonna hang on to both of these. All right. So vertical asymptote is 5. Okay. So my vertical asymptote So again, my vertical asymptote is we set the denominator equal to 0. So we have x is equal to 5. My factor is going to be x minus 5 down here. Okay, so right now, let's just take a look at this. I would have x squared plus x minus 20 divided by x minus 5. Now that's not my answer so far. That's just, this is all the stuff that I have up to this point. Okay. And now when they tell me the horizontal asymptote is 1, now they've given me some additional information. Because normally at this point, I'm looking at this 2 and this 1, and I'm thinking, oh no, are they going to make me divide? Oh, it turns out no, my horizontal asymptote is 1. And that means the degree of the top has to be the degree of the bottom. Well, they only gave me one horizontal asymptote or one vertical asymptote. So we're going to have to do that to make this a squared to match that, so that y equals 1 can be a horizontal asymptote. Okay, so I'm not jumping to this 2 here, right? I'm kind of making an argument as to why it has to be a 2. All right. And then y-intercept, right? That's when x is equal to 0. So if I set x equal to 0, we would get the point 0, negative 4/5. Okay. So what if I just plug in 0 and see what happens, right? So if I just plug in 0, we have negative 20, and then I've got what? I've got 0 minus 5, 25 down here. So this is 4 times 5, that's 5 times 5, and then we end up with a 4/5. I think there's a negative there too, yeah, from this sign, this sign, this sign. Well, that's good. We don't have to do anything else. Okay. If it was something else, right? If it turned into something else, then what we would do is we would multiply. We would say, okay, well, this is what I got without a constant. I'm just going to assume that there's something up in front here equals 1. I would say negative 4/5 times k is equal to 1, and then solve for that. Okay. But so far, every problem that they've dealt you out of this book, this has pretty much always been 1. So I don't think we need to go through and find one that does that. I just don't think there are any that is going to make that happen. But that's what you would do. Okay. So did they really multiply this out? Oh my goodness, why did they do that? X minus 5 squared, that's going to be x squared minus, right? Because there's a minus 5 and a minus 5, so minus 10x plus 25 on the bottom. So what do we have here? We have x squared plus x minus 20. So this one's a possibility, and the bottom one's a possibility, right? Because we're looking for that format, and that's the first and the third. And then the bottom looks like it's got x squared minus 10x plus 25. So I'm thinking it's that one. All right, and it didn't yell at me, so I'm pretty okay with that. Today's Wednesday, right? All right, so let's see here. What else are we doing? Let's go ahead and look at an inverse function. Okay, go on to the next one. So inverse functions, preview. Yep, start. All right, I hope you guys forgive me a little bit, because the stuff where you have to draw it, I was terrible with those. So I'm not really that interested in making you kind of sketch this on the other side. Okay, I don't think I asked you any like this, because yeah, my bias is I was terrible at this, and I've never had to do something like this outside of a math class. So I'm just going to let it go. If you know that this is how it works and you try to, you know, get it on the other side, then I'm happy. All right. All right. Okay, let's look at this one for a moment. Okay, so f of x equals absolute value of x minus 2 for x less than 0. Okay, let's see what we have here. So we have f of x equals absolute value of x minus 2, x less than or equal to 0. Okay, so what we're looking for is something like this, right? 1, 2, using our function transformations. We're going to have absolute value, right, which is here, and we're going to move it down 2 because that's a vertical shift. Okay. And they only wanted this part of it because they only wanted the x is less than 0 part. So we're looking at effectively this line down here. Okay, and that's what we have to figure out. Okay, so when x is less than 0, right, then we really have a negative x in here. So we could replace this. We could say y is equal to negative x minus 2. That's what we have over here. If you did not have, so again, things I wish we had in a face-to-face class. If you did not have this condition, would this function have an inverse, right? And that answer would be no, because this is not a one-to-one function. It fails the horizontal line test. So if we don't have this restriction, then we don't have a one-to-one function. So it does not have an inverse. All right. So let's go ahead and we're going to replace. So we're going to say this is x is equal to negative y minus 2, and then solve for y. So we have x plus 2 is equal to negative y. And why do we have, right, that's negative x minus 2. That should not, I don't think this is out of the same inverse. Okay, but that's apparently what we're getting here. So y equals negative x minus 2. That's our guy here. If I left it as the absolute value, let's just check out and see what happens here. Minus 2. We have x is equal to absolute value of y minus 2. Add this off to the other side, we get x plus 2. And at that point, right, we have y either equals x plus 2, right, or y equals negative x minus 2. Because when you break something out of a square root, you've got to have the plus part of it and the minus part of it. Okay, so it either equals itself or it equals exactly the negative of it. We could put this, right? We could say, you know, the step before this would be that one. Okay, so I guess that is our answer. It does have its own inverse. It's weird. So we have negative x minus 2. All right. Now, do you remember that the domain of the function was the range of the inverse? Okay. And the range of the inverse is the domain of the original. Okay. So they flip and flop that way. What is the domain? Well, they're going to want us to put the domain in. Okay. So I'm looking at this, and I think our domain is going to be, again, when x is over on this side. So x has got to be less than or equal to 0. Put my fingers on that one. Did not like it. That should be okay. Really, is it greater than 0? Tell you what, why don't we actually do it the way you should do it? So, my original function. Right. Domain. What's going on here? Right. Domain is x is less than 0. That's what they said over here. X is less than 0. What's my range for the original function here? Okay. The range for the original function is it has to be bigger than -2. Okay. So my range, -2 to infinity, yeah? -2 all the way up to infinity. So when I've got my inverse, right, the domain was that, okay? So the domain is -2 to infinity, right? My range here is going to be this piece. It's going to be x. All right. So this to me looks like x must be greater than or equal to -2. Equal to. Here. Okay. Trust the method. Don't try to eyeball it like I just did, because it'll mess up. All right, there we go. Did that. All right, this is a good one. We have a graph, right? We have f of x equals square root x minus 4. Okay, and they have us graph that. So remember, x minus 4, right? This is just a square root of x, and then we are pushed over to the right 4 units. Just do this. If I put 5, excuse me, if I put x equals 5, we get 5 minus 4, which is 1, and the square root of 1 is just 1. Okay, I hope that was okay to type that out like that. Okay. Right. Next, is it a one-to-one function? Sure is. God, I hope I asked this one. This is a good question. F is one-to-one function. Okay. The domain of F. It looks like everything bigger than 4, right? This is everything bigger than 4. So my domain here is 4 to infinity. Okay, that's my domain. And it includes 4 because we put 4 in there. We get 4 minus 4 to 0. The square root of 0? Yeah, we could do that. That's just 0. So my domain is 4, 0. That's my range. They're going to ask 0 and everything bigger. Okay. So when they're going to ask, this is for F, when they ask for F inverse, right, what's my domain going to be? What's my range going to be? Right, so we see that. So domain is going to turn over here. Range is going to be over here for F inverse, right? So my domain here is going to be domain of F inverse, and the range is going to be for infinity. Okay, so be careful about that because they will ask, and that's fine, but we're not going to get fooled. Okay, so the domain, what did we say the domain was? Domain was domain of F. So that's 4 off to infinity. So we need a bracket. There we go. So it includes 4 And then we are off to infinity. Right? And then the range, right? The range over here is 0 to infinity. So we're going to say, again, this one, we have 0 to infinity. All right. Now write the equation for f inverse. Finally. Okay, so this guy here, right? This f of x, we replace that with a y. And then what we're going to do is we're going to swap. So we get x is equal to the square root y minus 4. Now we're going to solve for y. All right. So this is going to be x squared is equal to y minus 4. Put this on the other side now, so we get x squared plus 4 is equal to y. But we know what this graph looks like, right? This is a parabola with a vertical shift of 4. We're good. All right. We have double check to make sure we're okay with that. We sure are. And x, now they want to know, like, is it greater than 0 or not? What is it? And it looks like the domain of my inverse here, right, is 0 to infinity. So x is greater than or equal to 0. It's weird. I wonder why they don't tell us put it in interval notation. I mean, they do everywhere else, right? So why wouldn't they do it this way too? But for whatever reason. Okay. Explain why the restriction is here. And the restriction is there is because, well, look at it, right? It's x squared plus 4. We found it because it was an inverse. But it makes sense to do that. Like, would this function now have an inverse? Like, no, but it is an inverse. So we can't have it on two sides here. We could just have it over on this side. So it's not going to pass the vertical or the horizontal line test. Okay, f has a restriction of x greater than 0. Okay. Oh, because f has a restriction that. So let's go back to f. Sorry. F has the restriction that x has to be greater than 4. 40, just 4. Okay. No. So x has to be greater than or equal to 4. Oh wait. We have to change. We have to compare the range to this thing because it's asking us about the domain of f inverse. So we have to compare it to the range of f. Okay, I didn't know I could have that as a choice. So f of x has to be has to go bigger than 0. Okay, that's better. All right, that's happier. All right, and then graph them on the same coordinate system. All right, that's a. All right. So, let's see here. We have x squared plus 4 is equal to y. So x squared plus 4, how is it going to go here? Now, if I just go, okay, so if x is equal to 1, right, we get y is equal to 5. All right, so that would be x equals 5. All right, and now we're going to snip, and we are going to cut this thing at 0, 0. Oh, there we go. 0, 4 is what I meant. And we are going to erase. that side of it. And that is going to be our thing. All right. Oh, we still have more. Okay. Oh, all right. The domain here of f inverse, that was 0 to infinity. So again, they're going to ask us the same question a couple of times. That was 0 to infinity. And our range was 4 and beyond. Just wrong one. Is 4 and up. All right, let me see if I can find a good one for us to do then. Oh, this is a good one. Okay, I will absolutely ask you to do the fraction one. Okay, this is a definite. Which means we should probably open up with this one tomorrow, right? Okay. So they give us a one-to-one function. Okay, we could even graph this if we really wanted to. Okay, write the equation for the inverse function. So we have v of x is equal to x minus 9, x plus 3. Okay. And the next thing we do is we swap and we say, okay, well, we write this y equals x minus 9, x plus 3. Okay. Now we're going to swap the variables. We're going to say x equals y minus 9, y plus 3. Okay, this is the swap. Okay, so my first step, second step, and then the third step is solve for y. All right, I'm just going to leave that as an algebra step, and we're just going to work through this. So we're going to say, right, we go ahead and make this not a rational equation. So we have x times y plus 3 is equal to y minus 9. Okay. Now we have xy plus 3x is equal to y minus 9. Right? Now, it really doesn't matter which direction you want to do this in. I'm going to go ahead and put this piece over there. Okay. And the minus 9 is going to come over here. The only reason I'm doing that is I'm looking at this like, oh, minus 9. If I put it over here, it'll be a positive number, a positive function. So we've got 3x plus 9, right? I don't have any negative signs, is what I really mean by that. And then on the other side, we have y minus, right, xy. Okay. Looks like I wasn't going to get away with having a nice function regardless of what I did. So what's common, right? Things that are common are my two y's. Those are common. We're going to pull those out of the function, or out of the equation here. So we're going to say this is y, 1 minus x is equal to 3x plus 9. And then we're going to divide both sides by 1 minus x. And then we're going to get our function of y equals 3x plus 9, 1 minus x. There's my inverse. All right. So this is going to be 3x plus 9. Oh, let's do it this way. 3x plus 9 over 1 minus x. So that's what we have, right? That's what we have over here. All right. Oh, that's all they wanted to do. All right. You guys are lucky because they don't make us verify that this is going to work. And if they did, so if we were in face-to-face and I said verify, okay, what we would have to do is we would have to take, well, what is f of f inverse and what is f inverse of f? Okay, so just to go back to this, do you remember doing this in 8.1 or 1.8 rather, where we have 3 times something plus 9 divided by 1 minus something? And what is that something? Oh, hold on, I'm looking at the wrong thing. This stuff is for the next thought. My function, x minus 9 over x plus 3. So we have something minus 9, something plus 3. And you know what we have to put in here? We have to put an f inverse. So this has got to be 3x plus 9, 1 minus x, minus 9. And then we have 3x plus 9, 1 minus x, plus 3. Okay. I don't know if you remember doing these in intermediate algebra or not. Okay, but this is what we'd have to go through in order to verify that it's inverse. Okay, so that's more fun than anybody should be allowed to have. Okay, let's see, should we do another one like this? Like that. Okay, x minus 1 over x plus 4. All right, and we have to find the inverse. Okay, we have to find the inverse. So what we're going to do is we're going to say x equals y minus 1, y plus 4. Okay, and then we're going to solve for y. Okay, so push this over, so we're going to have an x, y plus 4, and that's equal to y minus 1. So that's xy plus 4x is equal to y minus 1. Now, I got to get my y over here. Okay, it doesn't matter which order you do this in or which side you put this on. So let's do it that way. We subtract y from both sides, equals, and then we have negative 4x minus 1. Negative stays the same. Then we're going to say, well, this is x minus 1, because the y's are constant, right? They're common, right? The y's are common, and that is equal to negative. And I'm going to go ahead and write it this way. All right. And then at the end, we've got y equals 4x plus 1, x minus 1. All right, and that's how you put these things together. Okay, so it's important because I always ask the fraction one, because later on we get the logarithms. There's a skill you have to have finished in order to be able to do the logarithms, but it's the same skill for this thing as it is for logs. So this whole process is going to come back at you. All right, but that's okay. All right, so I think I'm going to go ahead and stop us there. I invite people to ask the questions for other things, okay, but I get it. So yeah, okay, we're going to go ahead and stop there. I'm going to stop recording, and we'll do a little bit more tomorrow. And if somebody has another question, if somebody has a question about, like, I need to see this one, I will happily entertain that. Okay, let me stop.